Good morning, everyone. Now we resume the next session. Before that, I would like to introduce myself. I'm Dr. Sharma, and I'm working as a capacity of assistant professor in TERI University. After a elaborative lecture by Dr. Kamna Sachdeva, I would be mostly talking about that how we can monitor the climate change. Okay, so before we have just learned that what is climate change and if it is a reality. In my slides, I would be mostly talking about how climate change can be monitored by means of various technologies. Okay, all of us know that our Earth's environment has not been, significantly changed in the past 10,000 years, right? It has been unusually stable. Okay, so this particular period of stability is known as Holocene. But because of the human activities, because of the industrial revolution, now there has been a threat to this stability. So this particular period is known as Anthropocene. Okay. So in order to deal with the challenges that are posed by this Anthropocene, I would like to introduce you first to the concepts of planetary boundaries. Okay, this was the framework, and planetary boundaries. This was the framework that was published in Nature, a very famous paper by Rockstrom et al. And it was published in 2009. And this framework was proposed in order to deal with the challenges that has been caused because of the Anthropocene. So what is this framework is all about? Well, in this framework, Rockstrom, they have proposed 10 important control variables. Okay, and those control variables and also the limits, the safe operating space limits of these planetary boundaries has also been defined. So these 10 control variables include climate change, ocean acidification, ozone depletion, nitrogen and phosphorus cycle, global freshwater use, land system change, biodiversity loss, aerosol loading, and chemical pollution. So if you look at this figure, you would be able to see the red and the green color. So where we see the red color, that means that this particular control variable has already crossed its threshold. It has already reached its threshold. So there are mostly three parameters that are already not in the safe operating space. So this includes rate of biodiversity loss, how the nitrogen has been removed from the ecosystem, and most importantly, climate change. So here we are mostly talking about the climate change. Apart from that, if you see the green colors, so that suggests that these are two control variables that are within the safe operating space, that has not crossed its threshold. That includes atmospheric aerosols and chemical pollution, but it is not yet quantified. So here if I talk about atmospheric aerosols, so why it has not been quantified? Because this is highly, spatially and temporally variable. Apart from that, if we see other parameters such as ocean acidification, phosphorus cycle. So here we can clearly see from this planetary boundary framework that since we are talking about climate change here, so climate change can be, it is mostly explained by the two variables. That includes CO2 concentration. We already know that it has reached up to 400 ppm. Apart from that, another concept that can explain climate change is radiative forcing. So in simpler words, if I say, radiative forcing can also be explained as change in Earth's energy budget because of the greenhouse gases and the atmospheric aerosols. So here we mostly talk about the climate change. So let us see what are the major challenges. Anyway, I won't be going into much details of the climate change because I will be mostly talking about how it can be monitored. Okay. So here we talk about the major issues and challenges that are posed because of the climate change. Here we can separate it into various categories, right? We can talk about the food security. It has posed challenges to the food security, to the water security. For example, if I talk in terms of atmosphere, I always talk about the CO2. So in 2050, it is projected that CO2 concentration would reach up to 480 ppm, right? If I talk about bioresources, we talk about deforestation and species loss. If I talk about climatology, we always talk about the increase in the global mean temperatures, right? If I talk in terms of ocean, we always talk about the sea level rise. So you will see, you will hear people talking about sea level rise, how it is increasing. We talk about melting of glaciers. We always talk about how their accumulation and ablation zone of glaciers are getting severely or significantly affected. We talk about the physical resources, how is it being exploited and how we are on the verge of losing all those natural resources. So these are the major issues and challenges that are being forced because of the climate change, right? So we had already done this with Dr. Kamna's lecture. So when there are significant issues, challenges, how we deal with it, right? How do we know that temperature are increasing? How do we know that glaciers are melting? That is the question, right? Because this could be measured by various means. So first important mean here is we can measure it with help of the ground observations, right? What can I do is I would go install a particular instrument at the glaciers, right? But physically, how would I go there? How do I measure that a particular glacier is melting, right? How do I go in the middle of the ocean and know that the sea level is rising? That is still a question. Because if I talk about ground instrumentation, even those data sets are questioned. Why? It could be because of the instrument artifacts, could be because of calibration of the instruments. And apart from that, there are certain regions that are not accessible to us, right? I cannot go into middle of the ocean anytime or every time when I want. I cannot climb a glacier whenever I want. I cannot have a physical, measurement of temperature every time. So how do I measure? How do I know that climate change is happening, right? So here the satellite remote sensing certainly can help us. So before we go into the details of how satellite remote sensing can help us in monitoring this, I should tell you that what remote sensing is, okay? So, well, remote sensing, it can be explained, if I go to the definition, so remote sensing can be explained as a science of acquiring information about the object without being in physical contact with the object. That means I need not to touch the object, but I can certainly retrieve information about it, okay? So this means there's no need of physically going there. What can I do is I just put up a satellite in the orbit and that would be measuring the required parameters that I want or I wish. So now my life is very easy, right? So this is how satellite remote sensing can help me. Apart from that, another advantage is it would provide, where the ground observation would provide me a single point based data. This can provide me the spatial measurements, right? So if I want to, have information about, let's talk about in terms of Delhi, right? So a ground instrumentation, I would just put up at a particular place, but satellite remote sensing would provide me the spatial observation. So I know about the temperature at whole of Delhi. So this is the kind of advantages that satellite remote sensing can offer me, right? So this is how satellite remote sensing can help me in monitoring those indicators of climate change. Okay, so then you would ask me the next question, that what are the systems that I can monitor with help of remote sensing? So well, this figure makes it very clear, and again this figure has been taken from the paper. There's a beautiful paper that has been published in Nature Climate Change, and the paper is by Young et al, and they had very nicely compiled all the information that how satellite remote sensing can help us in monitoring the climate change. So here we can see the remote sensing, when we can do it with the help of ground observation. Satellites can certainly measure the cryosphere, it can measure the aerosols, it can measure hydrosphere, the sea ice and atmosphere. It means we can measure now each and everything, all Earth's resources, okay. So the next question you would ask me, that tell me what are the satellites that are available to us that can help us in monitoring the climate, okay. But again, the another question would be, because as Dr. Kamna was talking, that climate change is in the longer periods. Here we are talking mostly about 100 years, but your satellite will not give us the data set. But that is the limitation, because satellite era came only after 1980. So effectively, the data sets that we have is primarily either for 20 to 10 years. But again, this is the great help to us, because at least now we have spatial observations. For example, if I want to know about the glacier retreat, if I want to, validate my information of the ground observation, I certainly have data sets over the last 10 years. These are the advantages, okay. So now what are the satellites that are available to me? What are the kind of satellites that I can use for measuring it? Okay. NASA, they have a very beautiful Earth observation systems, and it has a fleet of polar orbiting and and both geostationary satellites. Okay, so these are the both kind of satellites we can use for climate change monitoring. So polar orbiting are the satellites that move from pole to pole. Okay, these are normally located at the distance of 800 kilometers, and it would give me the data mostly, for example, for the same reason I can view after the 5 days. So it has a 5 days or maximum 3 days revisit capabilities. Apart from that, there are geostationary satellites. That means geostationary. That is stationary with reference to the Earth. So it is fixed at one position and it would give me the continuous and concurrent measurements about the particular position. So NASA has got its own fleet of both geostationary and polar orbiting satellites. To name few, there are various satellites. There are Aqua, then TERA, Landsat, then there is TRIM, TRMM, that is tropical rainfall measuring mission, and then we have the Calypso satellite. Apart from that, the QuickSat. So there are a number of satellites that are available by the NASA. Okay, but do India also has got its own satellites? The answer is yes. So India also has got its own fleet of both polar orbiting and the geostationary satellites, and it started with the Aryabhatta satellite that was first launched. Okay, so if we talk about the geostationary satellites of India, we have got a good fleet of INSAT satellites. Okay, INSAT, that means Indian National Satellite. Okay, so INSAT has got 23 satellites, and this is primarily used for communication purposes and weather monitoring, right? So when we talk about climate change, we also think about the weather. So INSAT satellites can help us in monitoring the weather. Apart from this, India has also got its own share of polar orbiting satellites. That is it has got a fleet of IRS, that is Indian Remote Sensing Satellite, and that is primarily used in mapping and monitoring the Earth resources. Apart from these two satellites, apart from these two networks, India is also coming up with several other, focused satellites. For example, we have OceanSat. OceanSat is primarily meant for measuring oceanic parameters, right? Apart from that, it has also got SARAL, that is satellite with Argos and Altica. This is also primarily meant to monitor ocean. Apart from that, there is Megatropics. So Megatropics, as the name says, Megatropics. Mega means cloud. So it is primarily meant to measure the cloud. So even India also has got its own expertise where we can measure everything right from the cloud to the natural resources. Okay. Apart from that, India is also, planning to launch the satellite that is GIG-SAT. It specifically means to monitor greenhouse gases. Okay. So here we see the capability. There are hundreds of satellites that are available, and if we assume that after 50 years, we would be certainly having a very good database of all these parameters, which could be certainly very much helpful, and it would also improve our efficiency in monitoring and mapping all the indicators that are there. Okay, so then the next question that you would ask me is that, okay, what is that we can measure with help of those satellites? Good that we have hundreds of satellites, but what is the use of these satellites, right? How can I use it, and what kind of data sets I can retrieve from it? So here, from the space-based inputs, we can map certain things. I have sorted it out into 3 categories. First is we map indicators of climate change. For example, glacier retreat is the one indicator. Change in the polar ice cover, bleaching of polar reefs. So there are several indicators that we can map, right? The next inputs that we can get from monitoring the agents of climate change. So as all of us know that mostly greenhouse gases, atmospheric aerosols, stress gases. So these are the agents. There are, we always held them responsible for the climate change. We always say that CO2 is responsible for climate change. We blame always aerosols, that aerosols are responsible for this. So these are the agents of climate change, which we can certainly monitor with the help of satellite remote sensing. Third category is if we want to model the impact of climate change. So if I want to monitor impact on food security, if I want to, monitor the impact on ocean productivity, these are all kind of space output variables that are available to me just from the satellite remote sensing. So since my expertise is in the monitoring the agents of climate change, I would be mostly talking about that how these parameters are monitored and how I can use it for the particular application. So here we talk about monitoring the agents of climate change, which is primarily GHGs, CO, CO2, NOx, methane, atmospheric aerosols. So the next question that should be posed to me is, so tell me now, what are the specific satellites that would help me in monitoring all these parameters? That includes greenhouse gas emissions, CO or CO2 or aerosols, or all those agents. So I have compiled a list for all of you that these are the most important focus satellites that are available just to monitor those agents of climate change. Okay, so there's at least more than 10 sensors that are available that gives us various variables, right? So if you see the first point, the variable is PM, that is particulate, stands for particulate matter. Okay, so particulate matter again is very important when I talk about the human health, right? There are people who study climate change and human health. So if I want to have information about it, so there is a MISR sensor, that is multi-angle imaging spectroradiometer, and it is on board TERI satellite. And here if you also see that there is spatial resolution in the sense that at one instant, how was the area that a satellite can view. So at a time, in one pixel, it can measure 1.1 by 1.1 kilometer area. And if we see the coverage, it is global. That means this satellite, there's no need of putting the ground instrumentation. It would provide me the global coverage throughout the world. And if we see the data period, it is available from 2000 to till date, we have 14 years of data sets, right? Then the next parameter is VV. That means this stands for vertical profile, right? So this is the latest satellite that was launched in 2006. And how is it important? For example, if I want to know that till what extent aerosols are present, so this would help me in understanding the vertical profile of individual pollutants. Okay, so here we see the coverage. Again, this is also global, and if we see the data that is available from 2006 to present, obviously just for 8 years. But again, a wealth of data set that is not available everywhere. Otherwise, what I have to do is I have to launch a radio sonde, or I have to, station a upper weather observatory. That is very expensive. Maintaining those weather observatories are very, very expensive. So the easy way for me is, working with these satellites, right? Apart from that, other parameter that we can extract from here is AI. AI stands for aerosol index. So before we were talking about aerosols, but absorbing and scattering, this can have different feedbacks on the climate. So again, absorbing aerosols are speculated to reduce the rainfall. So if I want to know if the aerosols are absorbing or scattering, then certainly OMI, that is ozone monitoring instrument, this is also meant for monitoring ozone. Okay, so this can certainly help me. And if we see the spatial resolution, is obviously coarse resolution, but again the coverage is global, and data are available from 1978 to till 2014, almost 30 years of data sets. So this is a wealth of data sets that are available to us, by which we can monitor both the ozone, apart from that the absorbing and scattering nature of the aerosols. Apart from that, if I'm interested in aerosol optical depth, that is a total, again, aerosol is, these are the, particles that are present in the atmosphere and that attenuates the solar radiation, very much harmful. And again, if you remember, this was also as a one control variable in the planetary boundary framework. Okay, so if you see, there's number of satellites that provide us this data sets on AOD. So that since this is more spatially and temporally variable, these satellites can certainly help us in quantifying these aerosols, so that we would also know that if this particular framework, this particular variable is also in the safe operating space, or it has crossed its threshold. Why we don't know about it? Because it is highly variable. So if I see in the range of, let's say, 2 kilometers, at each location this would vary. However, we do not have data sets on this. So this is highly unpredictable, but we have plenty of data sets from the satellite. Apart from that, if I'm interested in CO2 or if I'm interested in CO, so there are a number of data sets that are available to us. So these all satellites can help us in monitoring those events of climate change. Okay, so I hope this is all clear that now you know that what are the satellites that are available to us. Okay, so the next question would be, what kind of data sets I would be getting. So, okay, I would opt for those satellites, but what kind of data sets that I would be getting, and if a layman, if a person who does not have prior knowledge of atmospheric sciences, satellite remote sensing or meteorology will be able to utilize it? That would be the obvious question, right? So here I'm answering that question. So the kind of data set that we get here is, for example, the first figure, if you see, that is Asia and biomass burning. So this is showing the red spots and the yellow spots are showing fires over the particular region. This has been compiled for a few months, but here if you can see that there's almost, there's few regions of the India are not vulnerable to the fires. Otherwise, over all of the regions, we see number of forest fires that are occurring. So this information now I'm able to get. Okay, and this is available right from the 2000. So I have 14 years of data sets for the forest fire. Same way, if you see the next figure, and if you can see the different colors, the green, yellow and all, what does this mean? This is basically a transport of dust plume. So if I'm interested in knowing that how a dust plume is moving, right? So this information certainly I can get from the aerosol index. That is also telling me about the absorption properties of those particular dust particles. Okay, here another figure, if you see here, you can see the red colors. This is again aerosol index, which is telling me about how is dust is being transported. So if there is dust from in somewhere in the India, so if in the next 5 days, till what extent it would transport. This is obviously is not a climate change, but it's again short term. In short term frame of 5 days, what is happening? So when I can see the long-term changes, I can also see the short-term changes with help of all those data sets. And the fourth figure is about haze. Okay, so this here, if you see the thick white color, that is fog, and then how the smoke is spreading all over the India upward towards the Bay of Bengal. So all those transports, all those data sets, I can certainly access from the satellite remote sensing. So this is the beauty of this technology. Okay. So I would now just try to explain with the help of few case studies. But again, as I said, I won't be able to finish it off everything in the 45 minutes because time is just limited. So I'll just give you a few examples. The first example is here, what we did is we tried to see, even you would not believe that dust can get transported right from the Saharan regions. So it can, come all the way from sub-Saharan Africa up to Thar Desert. Right? It can move from sub-Saharan Africa towards USA. So even that is also possible. So whenever there is dust storm, don't think it is because of the Thar Desert. Don't always blame the Thar Desert, right? So it can even get transported from all various other regions. So here in this study, we tried to provide evidences that how it can move from one place to the other regions. Okay. So here satellite images, helped us in tracking the movement of the dust plume. So here we can clearly see that from the Arabian regions, it is getting transported towards the Rajasthan. Okay, so these kind of evidences we can get from here. Apart from that, it's not that satellite would just give me the qualitative data set. No, I can certainly retrieve quantitative analysis from it. Apart from that, I can also integrate it with various numerical models that are available that Mr. Saurabh Hagal would be capturing in his slides. So now we will just stop for the poll questions. We would be posing the poll questions to the both online participants and the in-house participants as well. So both of them can answer. So here's the poll question for you that says that which are the biggest sinks of greenhouse gases? So any guesses? Trees, or it is all of the above? So now let's come back to the lecture. Okay. Yeah, so we were talking about the long-range transport of dust aerosols. So here, as I said, it's not that I can just get qualitative information from this, but no, I can certainly integrate it with the numerical models. I can certainly put up all this information. I can integrate ground observations, satellite observations, numerical models, and certainly can come up to a particular conclusion. That's why we try to do it here. So here the another important evidence that we found is that mostly what happens whenever there is a low pressure system in the Bay of Bengal, that most of the time creates an high pressure over the Arabian region, and because of this low pressure, because of intense winds, this pulls up dust from these desert regions. So this is this most debatable, because many of the researchers say that no, this is not happening. This low pressure is not always responsible for the dust storm, but most of the time it has been found that whenever there is a cyclonic system, whenever there is a low pressure system in the Bay of Bengal, that mostly pulls up dust from the desert region and brings, here if we see that if there are most of absorbing aerosols present in the atmosphere, that are mostly, replaced by the dust aerosols. So here these evidences were provided by integrating the climate models, the satellite data sets, and the ground-based observation. So this was also supported by the INSAT satellite image. So that also showed a cloud system and dust originating from those regions. Okay, so these are the kind of studies that I can do. So this is not climate change, but here what we are doing is we are trying to monitor the indicators of climate change. So I can certainly monitor that how the aerosol plume is getting transported. Okay. Another case study that I would like to show you is, so then there's another, interesting case study that was done by Sagnik Day and Girolamo, and this paper was published in JZR, the Journal of Geophysical Research, and very highly reputed atmospheric science journal. So what they did is they tried to, analyze the aerosol climatology. That means the variability of atmospheric aerosols over the period of 10 years. So here what they did is they estimated, they observed aerosol optical depth, aerosol angstrom exponent, that mostly tells about the size, and they try to explain that over a period of time aerosol load has increased over India. So if we see in the last 10 years, aerosol load has highly increased, and if we see mostly Indo-Gangetic plain is primarily affected by it. But again, a latest research study suggests that now there is a decline trend even over Indo-Gangetic plain. So there is again interesting observation that I'm not showing it here, but there is another interesting observation that has come up, and that shows that now there is a declining trend in the aerosol load over Indo-Gangetic plains. But again, we are just not limited to the India. These kind of observations can also be done over the world, right? If I'm not interested in India, I want to look at the world. There are also kind of studies that are being done. So here there was a study done by Mies et al. And what they could do is they analyzed aerosol climatology during the period of 8 years, and what they said is there's a reduction over Europe and North America, but over India, in South and mostly East Asia, aerosol load has been highly increased. So this could be related to many more phenomena. For example, now people are talking about the solar dimming, right? So all this could be correlated. Apart from that, I'm not an aerosol biased person, but apart from that, there are also studies that are being carried out. For example, this is the paper published in JZR, and that shows the NOx pollution and it shows that it's mostly concentrating in the Indo-Gangetic plains, and it matched with the location of major diesel vehicular hotspots and then with the thermal power stations. It shows that how intensely the Indo-Gangetic plain is polluted, how much NOx, we are generating here. Okay, but so again, everything is all, it's not all about the spatial observations that are available to us. We can certainly integrate it with the climate model. It is nothing that is in monotonous. As I said, that we can certainly integrate satellite remote sensing, this technology, along with the ground observations that are available to us and the numerical model. Even as for today, now even if we see the forecast, that has been highly improved. Even now you would realize it. Earlier that used to happen that if IMD is forecasting rainfall, we never used to carry an umbrella, right? We would see that it would be sunny since IMD is saying that it is going to rain, right? But now that has improved, right? So if we talk about numerical simulations, that has been highly improved because even satellite remote sensing data is also playing a key role here. These data sets are assimilated and put it into those global climatic models, and that also certainly obviously there's a computation facilities that improves the accuracy. Apart from that, those spatial data sets are also very much helpful in order to improve the accuracy of the forecast. Okay, so as I said, we can certainly integrate it with the climate model, and it certainly help us in defining boundary conditions, and again in reinitiating models, updating variables, and also it helps us in validating and calibrating the models. Okay, but again, not everything is so green. I mean that everything has got its own limitation. When it can be certainly very much useful to us, when there are also limitations with the satellite data sets when we integrate it with the numerical models. Okay, for example, there is always there is spatio-temporal mismatch when we try to integrate it with the model. Spatio-temporal mismatch in the sense global models that work on the higher resolution, right? That works on the coarser resolution, but we try to assimilate the satellite data sets. This mismatch always happens. Apart from that, calibration is the problem. For example, what we do is we mostly retrieve the data sets from the relative transfer models. So when we are using those particular models, it has got certain schemes, right? And certain inputs. So if we are not using those inputs properly, that would cause problem when we assimilate it with the numerical models. Okay, so there are various limitations that are there when we integrate it with the global climate model. But apart from that, obviously this also offers advantages so that we can certainly improve upon the forecast. And we are seeing it now as forecast has been highly improved when we make use of all those data sets and assimilate it together. Okay. So last but not the least, if we are talking about the advantages of the technologies, we should also talk about the limitations. That what are the limitations of the Earth observation system? So I firstly said the short spans of satellite data sets. So even if it is available for 14 years, the span is really short. But if I want to monitor the indicator of climate change, I certainly need data sets for over at least 50 years. But if we look in the future, if we see in 2050, we would be certainly having a wealth of data sets that would be available and would be certainly very much useful in predicting and forecasting and also in monitoring the climate change. Apart from that, other limitation with Earth observing system is there are biases that are associated with instruments, because when we launch a satellite, it performs differently in the laboratory, but when it is launched in real time, when it is launched and put it into the extreme environment, it behaves differently. So problem occurs with the bias because after 5 or 6 years, instruments also did not behave as per the requirement. It would certainly have the errors. So that means I would not be getting the accurate data sets after let's say 5 or 6 years. So we have to certainly replace it. But again, this is a limitation. That's why we launch so many satellites, right? Here, apart from that, spatial resolution and temporal frequency. So as I said, if we want to know about, let's say, another control variable, that is aerosol, that is highly spatially and temporally variable. So 1 kilometer is not going to help me. 1 kilometer is too close. What I want is I want to have data sets that at least has a 100 or 200 meter spatial resolution, right? But that is a limitation because since I want a better frequency with better spatial resolution, but that is at the moment not possible. So mostly in future we would be able to have that. Calibrations, as I said, it behaves differently in the lab, but once it is launched into the extreme environment, its behavior changes. Okay. apart from that, when we try to merge data from different systems, what we want is, I want to study everything. I want to study CO2, I want to study, carbon monoxide, I also want to study NOx, but the satellites that I'm using are at different resolutions. Their spectral bands could be different, the temporal resolution could be different. So when it comes to merging these data sets, with the ground observations, with the numerical models, I'm in the mess, right? This is a problem. So this is again another limitation. Okay, so we still have to overcome these limitations. Apart from that, another limitations in Earth observing system is the uncertainties in retrieval algorithm, because the data that we get are not the real-time measurements, but they are retrieved. They're retrieved using particular algorithms that uses number of parameters. So obviously, when we are making use of the relative transfer models, we want various real-time observations. So it would depend upon the accuracy of the model would depend upon my inputs. So if my inputs are correct, my accuracy of the model also would be great, and particularly the outputs also would be very much accurate. So it also depends upon that each retrieval algorithm, because these are not direct measurements that you get from an instrument, but these are retrievals that are retrieved from a particular measurement algorithm. So this is also another limitations when it comes to the Earth observation system. Okay, so again, as I said, this is again a very good paper that was published in Nature Climate Change, and it has all compiled all the information very nicely. So we would be sending this along with the study material as well. But last but not the least, I would like to say thank you very much for the attention, and we can certainly make use of this technology just to map the indicators of climate change, and hopefully by 2050 we would be able to curb this issue that is called as climate change. Thank you very much.